Hello everyone, I welcome you back to the another session in this computer vision course series. In this session, we will be seeing what is Gaussian naive Bayes algorithm followed by its practical implementation. I know the name might sound a bit difficult, but trust me, the algorithm is just the opposite. I hope you will enjoy learning about this algorithm. So before diving into what Gaussian naive Bayes algorithm is, we need to understand what Bayes algorithm is. Have you ever felt that your search engine just read your mind while you were typing the search query? For example, if you search movie automatic shoelaces, you will be immediately shown the name of the movie Back to the Future. Has the search engine watched the movie? No. But how does it know that this particular movie has automatic shoelaces in its scenes? Well, the answer is it knows from the lots of other searches what people are probably looking for, and it calculates the probability using the Bayes theorem. Now, let's look at what Bayes theorem is. Bayes theorem is a way of finding a probability when we know certain other probabilities. Bayes theorem calculates the probability based on the hypothesis. It states that the conditional probability of an event capital A given the occurrence of another event capital B is equal to the product of the likelihood of capital B given capital A and the probability of capital A. It is given as follows. The above formula tells us how often A happens given that B happens, which is written as P of A by B. When we know how often B happens given that A happens, which is written as P of B by A, and how likely A is on its own, which is written as P of A, and how likely B is on its own, which is written as P of B. In the formula, P of A by B corresponds to the posterior probability, P of A corresponds to the prior probability, and P of B by A is termed as the likelihood and P of B is the marginal probability. Suppose you are planning a picnic today, but the morning is cloudy. Oh no, 50% of all rainy days start off cloudy, but cloudy mornings are common. About 40% of the days start cloudy, and this is usually a dry month. Only 3 of 30 days tends to be rainy, or 10%. What is the chance of rain during the day? We will use rain to mean rain during the day and cloud to mean cloudy morning. The chance of rain given cloud is written as P of rain by cloud. So let's put that in the formula. P of rain by cloud, which is equal to P of rain into P of cloud by rain divided by P of cloud. P of rain is the probability of rain, which is 10%. P of cloud by rain is the probability of cloud given that rain happens, which is 50%. P of cloud is the probability of cloud, which is 40%. Let's substitute those values in the formula. This results in 12.5% chance of rain. Not too bad. Let's have a picnic. Bayes theorem can be used to generate the following classification model. P of y given x, which is equal to P of x given y into P of x divided by P of y, where x is equal to x1, x2, x3, xn are list of independent predictors. Y is the class label. P of y given x is the probability of label y given the predictors capital X. Now, once you're familiar well with Bayes algorithm, we can move on to knowing what naive Bayes algorithm is. It is a supervised learning algorithm which is based on Bayes theorem and used for solving classification problems. It is mainly used in text classification that includes a high-dimensional training dataset. Naive Bayes classifier is one of the simple and most effective classification algorithms which helps in building the fast machine learning models that can make quick predictions. It is a probabilistic classifier, which means it predicts on the basis of probability of an object. Some popular examples of naive Bayes algorithm are spam filtration, sentimental analysis, and classifying articles. But the question is, why is it called naive Bayes? Well, the answer is the naive Bayes algorithm is comprised of two words, naive and Bayes, which can be described as naive. It is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of other features, such as if the fruit is identified on the basis of color, shape, and taste, then red, spherical, and sweet fruit is recognized as an apple. Hence, each feature individually contributes to identify that it is an apple without depending on each other. Bayes. It is called Bayes because it depends on the principle of Bayes theorem. Well, now I believe you are all set to learn the Gaussian naive Bayes algorithm. So let's get started. Gaussian naive Bayes is a variant of naive Bayes that follows Gaussian normal distribution and supports continuous data. It supports continuous valued features and models each as conforming to a Gaussian normal distribution. It can be expressed as given below. Sometimes we can also assume variance. It is independent of capital Y or independent of capital Xi or both. An approach to create a simple model is to assume that the data is described by a Gaussian distribution with no covariance between dimensions. This model can be fit by simply finding the mean and standard deviation of the points within each label, which is all what is needed to define such a distribution. The above illustration indicates how a Gaussian naive Bayes classifier works. At every data point, the z-score distance between the point and each class mean is calculated, namely the distance from the class mean divided by the standard deviation of the class. Thus, we see that the Gaussian naive Bayes has a slightly different approach and can be used efficiently. Thank you.